Here's problem 725. A compressed spring is used to launch a skier up an icy ski slope with a 20-degree incline. How far up the incline the skier travels may depend on the following factors. 1. The skier's mass. 2. How far the spring is compressed. 3. The force constant of the spring. 4. The angle of the incline. And 5. The value of the gravitational constant g at that location. To find the distance up the slope, we do not need to know which of those factors. Well, let's think about this. Ultimately, we want to find the distance up the slope, and this is really a conservation of energy type problem. Let's take a look at this. Here's our incline of some angle theta, and we have a skier here, and they're going to go up some distance d up this incline. Let's take this d all the way down here, and we have a spring down here that is going to launch us of spring constant k. So we're going to go up some distance, some height h. As we look at this triangle, h is going to be equal to d sine theta. Sounds good. In terms of energy, we could say that all the energy of the compressed spring will go into our gravitational energy, potential energy of height. So we will have to say that 1/2 kx squared is going to equal mgh in this case. So h is going to equal 1/2 kx squared divided by mg, or we could say that h is going to equal kx squared divided by 2mg. Sounds good. But we can add that h is also equal to d sine theta. So as we solve this for d, we would have d is equal to kx squared divided by 2mg sine theta. So this is ultimately the distance that we are going to go up the incline, and it's related to all these factors. So the distance d is related to the spring constant, so we need to know that, force constant of the spring, so we need to know this. It's related to how far the spring is compressed, x, so we need to know that. It's related to the angle of the incline of the slope, so we need to know that. It's related to the value of the gravitational constant g at that location, so we need to know that. And it's related to the skier's mass, m, so we need to know that. So we need to know all 5 of these things in order to locate the distance d. So there's no answer for us to choose here. There's no thing that we don't need to know. We need to know all 5 of these things, and hence there's no answer that we can choose here.